Guys, sorry, we had more visitors. I apologize. It's just been, I think, really crazy here today with Breakfast for Santa and all that really fun stuff with like the holiday sale. Okay, so we're trying to find the resistive force, and we know that this is our equation. But again, we're kind of stuck because what happens, we don't know the drag coefficient. We don't know, they didn't give us the cross-sectional area for this baseball, for this object. And I don't know density. I could probably find density of air, like I know that, but it still doesn't help me because I don't know this and I don't know this. So that means let's try to do something where we can substitute in some variables where maybe we could cancel some things out here. So that's my goal. I don't know these things, so I'm going to have to try to figure out a way to use information that I have and that I do know. Well, I do know that this drag coefficient, cross-sectional area, the density, and mass and acceleration due to gravity are all related to terminal speed. And I know that because Vt is equal to, if I'm thinking about when r is proportional to v squared, I know that Vt is equal to the square root of 2mg over that drag coefficient times rho times a. So we do know that. I know m, I know g, I know Vt. If I solve for one of these variables, I could plug it in up here for that, and I bet anything they would cancel out. So let's check it out. Let's just say that we're going to solve here for the drag coefficient. So if I rearrange this formula to solve for d, I'm going to end up getting d is equal to, that would be 2mg over Vt squared times rho times a. Okay, let's plug all of that in up here for d. So now r equals 1/2 times, let's do all of this, 2mg over Vt squared rho a. And then that's times rho times a times v squared. Okay. Well, if I look at this now, rho's going to cancel out, a is going to cancel out. So let's rewrite this. R then would be equal to, that 2 is going to also cancel out then with that 1/2. So this is going to simplify down great. So we're going to have our mg, and then let's do, that would be over v squared over vt squared. Or I could have done v over vt and then have that whole thing be squared out there. And I know mass, 0.145. I know g, 9.8. I know v, 40.2. I know terminal speed, 43. So that means I could find r. Guys, when you plug those numbers in, we should get our resistive force to be equal to 1.2 newtons. Okay, so thinking about that then, that's the resistive force then that's acting on that baseball at that 40.2 meters per second. If we were to think about the weight force, here, because remember that terminal speed happens when resistive force is equal then to the weight force. So if we're thinking about, we know our resistive force was at that point 1.2 newtons, and the speed was 40.2. Terminal speed is 43 meters per second. So this should be really, really close to the weight force. So this is a way I could possibly check. I could find the weight force because we were given mass 0.145 kilograms times 9.8 meters per second squared. That should give us a weight force about 1.4 newtons. So right now that resistive force is 1.2, and that speed of that baseball is at 40.2 meters per second. The weight force is 1.4 newtons, and I know that When the resistive force is the 1.4 newtons, that's when I'm going to get 43. So we're really close. We're really, really close to reaching terminal speed. So this resistive force must be accurate because my speed was 40.2 here. I'm trying to get to that 43, which is that terminal speed. So this is just another way that we could maybe conceptually check that we're right on track. Okay, because we're going to stop here. The next one is just about a skydiver, and you can read that on your own if thinking about it conceptually. So these will be posted immediately. I'll get them up, and you will still have homework questions that will be due on Monday, so please make sure that you have those done and ready for Monday. I will be grading them for accuracy, so please make sure that you have them, and we will continue on with doing some more practice problems from this chapter. I am thinking we'll do a quiz over this on Wednesday, okay? I will see you guys on Monday. Have a great weekend. Bye.